In a sealed lab, a small chip hangs at the bottom of a golden tower of wires and pipes. The machine around it cools that chip to a hair above absolute zero, colder than the empty space between stars. Inside, a few tiny circuits do something no normal computer can. Each one holds a 1 and a 0 at the same moment, right up until someone checks. Physicists built these machines to crack hard problems. What they opened was a window. To make the machine work at all, reality has to bend in ways that should be impossible. One thing sits in two states at once. Two particles share a single fate across any gap. And the plain act of looking seems to decide what is true. The machine runs. The answers come out right. And a quieter question keeps rising underneath them. What is really there, when no one is watching? The gold tower in the photographs is a refrigerator. The wires and plates and looping pipes are there to pull heat away, layer by layer, until they reach a chip the size of a fingernail hanging at the very bottom. That chip is the computer. Everything above it exists to keep it cold, and it has to be impossibly cold. The machine drives the air around that chip down to about 1/100th of a degree above absolute zero. Nothing in the wild universe is that cold on its own. Empty space, far from any star, still sits warmer than this. To run the chip at all, engineers had to build the coldest known spot in existence and put it on a lab floor. The reason comes down to one simple fact. Heat is just motion. The warmer a thing is, the harder its atoms shake, and shaking is noise. The chip holds its state only when nothing around it twitches. So they freeze the world near it almost to a standstill, because a single stray flicker of warmth can wreck the calculation before it begins. Inside that stillness, the chip does something an ordinary computer never could. Your laptop works with switches. Each switch is on or off, a 1 or a 0, and it is always one or the other. You could open it up and check. The answer was already there. The circuits on this chip do not work that way. They hold a value that has not been settled, not hidden from us, not too small to read, undecided. The math that runs the machine treats each circuit as holding both answers at once, and it only lands on one when something checks it. That sounds like a figure of speech. It is not. The whole machine is built on the idea being literal. If the circuit secretly held one fixed answer the entire time, the computer would not work. It needs the in-between state to be real, and engineers stake billions of dollars on it being real, because the machines they build on top of it come out right. So the cold is not the strange part. The cold is just plumbing. The strange part is what the cold protects. A working device, sitting in a lab, that depends on the world not having decided yet. And once you accept that one circuit can sit in two answers at once, a harder question opens up underneath it. If the answer is not set until something looks, then what exactly is the looking doing? Does the chip pick its answer the instant we check? Or was the pick always coming, and we just could not see it? Physicists have a name for the thing that does this. They call it the basic building block of the machine, the smallest piece that carries the trick. And to understand how a fingernail of metal can hold the future open, you have to understand that single piece first. It does not look like much. On the chip, it is a tiny loop of wire, cooled and tuned, no bigger than a speck. But that speck breaks the oldest rule in computing. It refuses to be just one thing. For 100 years, the people who study this have argued about what it means. They do not argue about whether it works. It plainly works. They argue about what is actually happening down there in the cold, in the dark, when no one is reading the answer out. That argument is where this story is going. It starts with that single speck, and the impossible thing it does. Picture a coin spinning on a table. While it spins, you cannot call it heads or tails. It is a blur of both. We usually treat that as the limit of our eyes. The coin is really one or the other at every instant. We just cannot freeze it. The speck on the chip is not like the spinning coin. It is like a coin that genuinely is both faces while it spins, and only becomes one when you slap your hand down. Physicists call this speck a qubit. An ordinary bit is a 1 or a 0. A qubit is a 1 and a 0 held together in a balance that tilts only when you measure it. This is the part people stumble on, so sit with it. The qubit is not flickering fast between the two. It is not secretly one value that we are too slow to catch. The mathematics that describes it carries both numbers at the same time, with a weight on each, and the machine uses both weights to do its work. Strip one of them out and the device stops computing. Both have to be there at once for the answer to come out right. This in-between state has a name. They call it superposition. The word just means the qubit is in a blend of its choices until the moment of the check. Stack 2 qubits together and you do not get 2 blends side by side. You get 4 possibilities held at once. 3 qubits hold 8. Add qubits, and the count of held possibilities doubles with every single one. A few hundred qubits, all in superposition together, would hold more possibilities at the same instant than there are atoms in the visible universe. That is the engine. The machine does not try one possibility, then the next, the way your laptop would. It loads the whole field of them into a state, works on all of them together, and then squeezes the result down to the one answer you wanted. The trick is real. The hardware proves it every day. But notice what we have already agreed to. We have agreed that a thing can hold many answers at once, and only fall to a single answer when it is checked. We have built a working machine on that. And we have not said one word about why the check should matter at all. Hold the coin image one more second, because it hides the puzzle. With a real coin, slapping your hand down does not change anything. The coin was going to land heads or tails on its own. Your hand just stopped it where it already was. The qubit is not like that. And this is the heart of everything that follows. As far as the math is concerned, the answer is not sitting there waiting for your hand. The check itself seems to be the moment the answer comes into being. Before the check, both. After the check, one. And the line between those two has never been explained. You might think this is a quirk of strange new hardware. It is not. The same effect showed up long before anyone built a quantum computer in an experiment so simple you could almost run it on a kitchen table. That experiment is where the dread really starts, because it does not just say a particle can be in 2 states. It shows the particle changing what it does the instant you try to watch. Fire a stream of tiny particles at a wall, not a beam of light yet, just particles one at a time, like firing single grains down a tube. In front of the wall, put a barrier with 2 narrow slits cut in it. Behind the barrier sits a screen that records where each particle lands. Run it 1 grain at a time, slowly, and watch the marks build up on the screen. You would expect 2 stripes. Each particle goes through 1 slit or the other, like a ball through one of 2 open doors, and you should get 2 clumps lined up behind the 2 openings. That is not what you get. Over thousands of single shots, the marks build into many stripes. Bright bands and dark gaps spread across the screen. That stripe pattern has a known cause. It is what you see when waves overlap. Where 2 waves rise together, they add up bright. Where one rises as the other falls, they cancel into dark. The screen is showing wave behavior, but you were firing single particles one at a time, with long gaps between them. There was never more than one in the machine at once. There was nothing for each particle to overlap with except itself. The only way the math works is if each single particle went through both slits at the same time and met itself on the far side. One grain, two paths, a wave of pure possibility passing through both openings and interfering with its own self before it hit the screen and became a single dot. Strange, but maybe you can live with it. So you try to catch it in the act. You place a small detector at the slits, just to see which one each particle really goes through. A fair question. You are not blocking anything. You are only looking. The pattern dies. The instant you can tell which slit each particle used, the many stripes collapse into the two plain clumps you first expected. The particle stops behaving like a wave through both doors and starts behaving like a grain through one. Turn the detector off and the stripes come back. Turn it on and they vanish. The only thing you changed was whether the information existed for anyone to know. This has been done countless times, in countless forms, with light, with electrons, with whole molecules. It is one of the most checked results in all of physics. It is not a trick of clumsy equipment nudging the particle. Physicists have built versions gentle enough to rule that out. The deciding factor is not a bump or a push, it is knowledge. Whether the path could be known. Sit with how upside down that is. A particle behaves one way when its root is a secret, and another way when its root is on the record. The universe seems to care about what can be known about it. And the change is not gradual. It is a clean switch, thrown by the simple fact of a path becoming knowable. So now the loose thread from the qubit pulls tight. It is not only that a thing can hold two states, it is that the act of looking reaches in and forces the choice. The particle was a spread of possibility, and the look pinned it to one spot, which leaves the question no experiment has yet answered. What, in plain terms, counts as looking? A human eye? A detector? A single atom getting in the way? Somewhere between the open possibility and the single fact, a line gets crossed. Nobody can tell you where that line is or what crossing it actually does. Before anyone looks, the math describes a particle as a spread. Not one position with some blur of error, but many positions held together, each with its own weight, all genuinely there in the description. The equation that does this is the most successful in the history of science. It has never once been caught giving a wrong prediction. Every prediction it makes is a probability, a spread of where the particle might turn up. Then you measure, and the spread is gone. One position, one value, one fact. The many possibilities that the equation insisted were real a moment ago have collapsed to a single point, and the rest have simply vanished, as if they were never weighted at all. Here is the crack that runs through the whole field. The equation describes the spread beautifully. It says nothing about the collapse. There is no term in it for the moment of measurement, no rule for when the many become one, no account of what a measurement even is. The smooth, reliable math covers everything right up to the instant you look, and then stops, and a different thing takes over that the math does not contain. They call this the measurement problem, and the plain word problem is doing a lot of work. It is not a small gap waiting to be filled in. It is a hole at the center of our best theory of the world. We can predict the odds of every outcome to staggering precision. We cannot say what happens in the act that turns odds into an outcome. You can feel how strange this is with a famous thought experiment. A cat in a sealed box. A single particle whose decay is a 50-50 chance. If it decays, a mechanism releases a poison and the cat dies. If it does not, the cat lives. The particle, untouched, sits in superposition, decayed and not decayed at once. The trigger is tied to the particle. The poison is tied to the trigger. The cat is tied to the poison. So, by the cold logic of the equation, until someone opens the box, the cat is in a blend too. Alive and dead together. Not unknown. Both. The point of the cat was never to claim a real cat lives in two states. The point was to drag the weirdness up from the world of single particles into the world of ordinary things and force the question. Where does the blend stop? A particle can be in two states. A cat clearly cannot. So somewhere on the chain from particle to trigger to poison to cat, the many possibilities have to become one. And the theory will not tell you where. This is the silence that should unsettle you. Not a wrong answer. No answer. The people who use this theory every day, who build the cold machines on it, who bet careers and fortunes on it, cannot agree on what happens at the most basic step. They run the equation. They get the right odds. They look. They get the one result. And the middle, the becoming, stays dark. For a long time, you could file this under philosophy. The math worked. The bridges held. Why lose sleep over what looking does if the predictions come out right every time? That comfort had an expiration date, and it ran out the moment two particles got tangled together. Because then the question was no longer about one thing turning from many into one. It became a question about two things, far apart, that turn into one fact at the very same instant. And that is where even Einstein decided the theory had gone too far. Take two particles and let them interact in the right way, then send them apart. They now share a single description. Not two descriptions that happen to match. One. The math no longer has a separate state for each particle. It has a single state that covers the pair, no matter how far you carry them from each other. This is entanglement, and it does something that should not be possible. Measure one of the two, and you instantly know something certain about the other. Say the rule between them is that their spins must be opposite. You measure your particle and find it spin up. In that instant, you know, with no delay and no doubt, that the far particle is spin down. Before your measurement, neither had a settled spin. Both were in the blend. Your check did not just reveal your particle, it seems to have settled both. Carry the second particle to the far side of a city, to the far side of the planet. The math says nothing changes. The pair stays one linked state until a measurement on either end forces both to take definite values together at once. Experiments have done this across miles of fiber, across open air between mountaintops, between the ground and a satellite in orbit. The link holds at every distance tried. Now feel the size of the problem. When you measure your particle and it settles, the other particle settles in the same breath, faster than fast. There is no time for a signal to cross between them, not even at the speed of light. If your particle somehow told the other one how to land, that message would have to travel infinitely quickly, and nothing is supposed to outrun light. That rule is the backbone of modern physics. It is what keeps cause before effect, what stops the future from leaking into the past. Einstein looked at this and refused it. He called it spooky action at a distance, and he did not mean it kindly. To him, an instant link across any gap was not a discovery. It was proof the theory was missing something. The universe, he believed, did not work by spooky tricks. Things had definite properties whether you looked or not, and nothing could shove another thing faster than light. Quantum mechanics broke both of those, so quantum mechanics had to be incomplete. And he had a clean way out, one that sounds like simple common sense. What if the particles were never really undecided? What if, at the moment they split apart, each one quietly took a fixed set of instructions, like a sealed letter it carries along? Your particle was always going to read spin up. The other was always going to read spin down. They match because they were stamped to match at the start, back when they were together. No spooky link, no instant signal. Just two sealed letters, written before the journey, opened far apart. It is a deeply reasonable idea. It saves everything Einstein cared about. The particles are real and definite the whole time. Nothing travels faster than light. The match is just bookkeeping from a shared past. Most people, hearing it, feel the relief of it. Of course, that is what is happening. The answers were written down in advance, and we only just looked. For decades, that was where it sat. Two camps. One saying the particles are genuinely undecided and linked across space. The other saying they carry hidden, settled answers and only seem linked. And no way to tell them apart because either way, the measurements come out the same. It looked like a question you could argue forever and never test. Einstein died believing the hidden answers were there. He was sure a calm, ordinary reality lay underneath the strangeness, waiting to be found. He just could not prove it. And he never knew that the question he thought was unanswerable was about to get an answer. The challenge Einstein raised was sharp, and he raised it with two younger colleagues in a short paper that landed like a thrown glove. Strip it down, and it is a single claim. The particles carry their answers with them. There is a real, definite world underneath. The measurements only read off what was already there, and nothing reaches faster than light to coordinate it. Two ideas locked together. The world is definite before you look, and the world is local, meaning no instant influence across distance. Put together, people call it local realism. Local for no faster than light tricks. Realism for properties that are real before measurement. This is not some fringe position. It is the picture of the world almost everyone walks around with. The moon is there when you're not looking at it. A coin in a closed box is already heads or tails. Things have definite states. And to learn them, you just check. Local realism is common sense written as physics. Einstein was not being stubborn. He was defending the most natural belief a person can have about reality. Against him stood the strange new theory, which said the opposite on both counts. Properties are not definite until measured, and entangled particles do influence each other across any distance, instantly. The theory was winning every experiment, but it offended something deep, and Einstein bet that the offense was a clue. He bet that the strangeness was a mask over a normal world we had not yet uncovered. For 30 years, his bet just sat there. It read like a matter of taste. You could believe in the hidden sealed answers, or you could believe in the spooky link. And since both gave the same predictions for every test anyone could imagine, choosing between them felt like choosing a favorite color. Real physicists mostly shrugged and used the math, because the math worked no matter which story you told about it. That shrug was the trap. Everyone assumed the two pictures could never be pulled apart by experiment. The whole point of the hidden answers was that they reproduce the quantum predictions exactly. If they matched on every prediction, what could possibly distinguish them? The question seemed to belong to philosophy, not the lab. You could argue it over dinner, but you could not bring it to a measuring device. So the field settled into a quiet truce. The theory was a tool. You fed it a setup, it gave you the odds were always right. Whether there was a hidden, definite world behind the odds, or a web of instant links, was treated as a private matter, a thing you believed on the side. The machines did not care. The bridges held either way. And underneath that truce, a real fact about the world was being decided, and nobody could get at it. Either Einstein was right and reality is the ordinary, definite local thing we all assume, or he was wrong and reality is something stranger than anyone wanted to say out loud. Not a matter of taste, a fact. The kind of fact that should have an experiment attached to it. There just was not one. Most people in the field believed there never would be. The two stories were built to be identical in their predictions. Telling them apart looked impossible in principle, not just in practice. Einstein's bet seemed destined to stay a bet, settled by belief and temperament, argued in words forever. Then one physicist sat down and found the crack. He noticed that the two stories were not perfectly identical after all. In one very particular kind of experiment, they parted ways. They predicted different numbers, and a difference in numbers is something you can measure. His name was John Bell, and what he found is so simple it can feel like a magic trick, though there is no trick in it. He asked a question nobody had thought to ask in quite the right way. If the particles really do carry hidden, sealed answers, written in advance, is there any measurement where that would show up as a different result than the spooky theory predicts? The trick was in not measuring the same thing on both particles. Instead of always checking spin along one direction, you let each side choose, at random, between a few different angles to measure along. Sometimes both sides happen to pick the same angle. Often they pick different ones. You run the pair through this over and over, thousands of times, each time noting which angles got chosen and what came out. Then you tally how often the two results agree. Here is the heart of it. If the particles carry sealed answers, fixed before they left, then there is a hard limit on how often the two sides can agree across all those mixed angle choices. The answers are written in advance, so the bookkeeping can only stretch so far. Bell worked out exactly where that ceiling sits, lay out the numbers, and a definite limit appears. With sealed answers and no faster than light tricks, the agreement between the two sides cannot climb past a certain value. Call it the ceiling that any ordinary, local, definite world has to obey. Then he ran the same calculation for the spooky quantum theory, the one with no hidden answers and a real link across space, and it broke the ceiling. At certain combinations of angles, the quantum prediction said the two sides would agree more often than any sealed answer story could ever allow. More agreement than a definite local world can produce. That is the whole of it, and it is staggering. The two pictures were not identical after all. They agreed on most things, which is why the truce had held. But at these special angles, they split. One said the result must stay under the ceiling. The other said it would climb past. The difference was not a matter of belief anymore. It was a number, and the number was different in the two worlds. So the question Einstein thought was forever stuck in philosophy turned out to have a door into the lab. You did not need to peer inside the particle and catch its hidden answer. You did not need to win the argument with words. You just needed to run the angles thousands of times, add up the agreements, and read off whether the total stayed under the ceiling or rose above it. Under the ceiling, and Einstein was right. A definite local world, with sealed answers all along, over the ceiling, and Einstein was wrong, and reality is the strange thing, with no settled answers underneath and links that do not care about distance. One number, separating two completely different versions of what is real. What makes this almost unbearable is how close the test came to never existing. For 3 decades, the smartest people in the field assumed no such test could be built, that the two stories were locked in a perfect tie. Bell showed the tie was an illusion. There was a place where they came apart, and at that place, a machine could decide between them. The math was airtight. The split was real. All that remained was for someone to actually build the thing, fire the particles, set the angles, and let the universe answer a question Einstein had died, believing could never be put to it. Building it was brutal. You need pairs of entangled particles, made clean and fast. You need detectors at each end that can switch their measuring angle at random, quickly, before any slow signal could sneak across and spoil the test. You need to catch enough pairs to trust the tally. The first real attempt came from a young physicist working with borrowed and homemade gear, and the early result already leaned one way. Then a sharper version followed, with fast switching that flipped the angles while the particles were already in flight. Too late for either side to quietly conspire with the other. The number came in. It broke the ceiling. Not by a hair, in a way you could argue about. It broke clean, again and again, run after run, exactly where the quantum prediction said it would, and far past, where any sealed answer world could reach. The agreement between the two distant detectors climbed higher than a definite, local reality is allowed to produce. The universe was tested against Einstein's calm, ordinary picture, and the universe came back on the side of the strangeness. Sit with what that means, because it is one of the heaviest results science has ever produced, and it is delivered so quietly that most people have never heard it. The experiment did not just say quantum mechanics is a good theory. It said that local realism is false. The world is not both definite and local. One of those two comforts, at least, has to go. The sealed letters were never in the particles, or the link across space is real, or both. But the ordinary picture, the one everybody carries, the moon is there when you're not looking and nothing reaches across space instantly. That picture cannot be the whole truth. The numbers forbid it. This is not one lab's opinion. The test has been run by group after group, on different continents, with light, with atoms, with whole separate technologies, for decades. The ceiling breaks every time. The result was judged so fundamental that the people who first nailed it down were given the highest prize in physics. Not for a gadget. For closing a question Einstein thought could never even be asked, and answering it against him. And here is the part that turns a result into a feeling. Einstein was not wrong because he was careless. He was as careful as anyone has ever been. He bet on the most reasonable thing in the world. The thing every one of us believes without thinking. That objects have real properties before we check, and that nothing can reach out and touch something far away in an instant. The experiment says that reasonable thing is not how the world works. Reality declined to be ordinary. If this is the first you are hearing of it, you are not alone, and it is worth a second of your day to let it land and to follow where it goes from here. Subscribe and stay with it, because the strangeness only deepens from this point. The honest among the experimenters were quick to admit the early test had gaps. Small ways the universe could, in principle, still be hiding an ordinary explanation. A clever skeptic could point to a loophole and say, "You have not truly closed the door, the sealed answers might still be there, slipping through the cracks in your setup." Those loopholes were real, and they mattered. So the field set out to close them, every last one, all at the same time, in a single experiment that would leave the ordinary world nowhere left to hide. That hunt took years, and when it finally succeeded, the door did not just shut, it was sealed. There were 3 main escape routes, and each one let a stubborn believer keep the ordinary world alive. The first was about detection. Early experiments only caught a fraction of the particle pairs, and a skeptic could argue the missed ones were quietly behaving themselves, so the ones you saw gave a false picture. The second was about distance and timing. If the 2 detectors were too close, or switched too slowly, There was technically enough time for a hidden signal to crawl from one to the other and rig the result. The third was about the choices themselves. What if the random settings on each detector were not truly free, but somehow nudged in advance by the same hidden causes that set the particles? Each loophole had been closed on its own, in separate experiments, but a determined skeptic could always say you plugged one hole while leaving another open. To truly end it, you had to slam every door in a single run, all at once, with no gap left anywhere. That experiment was finally built, and the centerpiece of one famous version was a pair of diamonds. Inside each diamond sat a single trapped electron, the thing to be measured. The two diamonds were placed in separate buildings, far enough apart that light itself could not cross between them in the time the measurement took. That distance alone shut the timing loophole. No signal, not even at light speed, could carry an answer from one side to the other fast enough to cheat. To close the detection loophole, they used a clever method that almost never missed. Nearly every event that should have been counted was counted, so there was no large pile of unseen results for a skeptic to blame. And to close the freedom of choice loophole, the detector settings were chosen by fast random generators, in some versions even seeded by light from distant stars, so the choices could not have been quietly arranged in advance by any local hidden cause. Everything closed, at once, in one experiment, the particles measured, the settings chosen freely and too late to coordinate, almost no events missed. Every door that an ordinary local world could have slipped through, shut and locked in the same run. The ceiling broke anyway. The result stood, cleaner and harder than ever. Local realism does not survive even when you remove every excuse. The world is not a place of sealed answers and respectful distances. Other groups race to confirm it with their own loophole-free setups, using different particles and different tricks, and they all landed in the same place. The verdict was no longer one experiment's claim with an asterisk. It was settled, fully, with every reasonable doubt addressed and dismissed. This is the moment the question stops being safe. As long as a loophole was open, you could tell yourself the ordinary world might still be down there, hiding. Now you cannot. The escape routes are gone. The data does not just suggest reality is strange, it corners you into it. So you are forced to ask the obvious next thing. If local realism is dead, what exactly are we left holding? The experiment tells you what is not true. It does not tell you what is. And when you lace out the choices that remain, every single one of them costs you something you did not want to give up. The result is a fork, and both paths take something from you. Local realism was two beliefs welded together. Realism that things have definite properties before you look. Locality that nothing influences anything else faster than light. The experiment says you cannot keep both. At least one has to go. So you are standing at a fork, and you have to pick which comfort to abandon. Take the first path and give up realism. On this path, particles really do not have definite properties before measurement. The spin, the position, the value, none of it exists as a settled fact until something checks. Before the look, there's only a spread of possibilities, genuinely undecided, with no hidden answer underneath. The measurement does not reveal a fact that was already there. It creates the fact in the act of measuring. The moon, in the strict version of this, has no definite location until something interacts with it. Reality, at its base, is not a set of things with properties. It is a set of tendencies that only firm up when poked. That is hard to swallow. So look at the other path, and give up locality instead. On this path, the particles can keep their definite properties. But now they are genuinely linked across space, and a measurement on one truly does reach out and affect the other, instantly, across any distance, with no regard for the speed of light. The spooky action Einstein hated is simply real. Touch one particle and you touch its partner across the galaxy in the same breath. The universe is sewn together by threads that do not care about distance at all. Neither of these is a small adjustment. The first says there is no solid, settled world underneath, only possibilities that crystallize when observed. The second says the whole fabric of space is shot through with instant connections that violate the rule we thought protected cause and effect. One guts the idea of a definite reality. The other guts the idea that distance keeps things separate. And there are stranger forks beyond these two, which we will reach. But even the gentlest reading of the experiment lands you here. The plainest, most cautious summary a physicist can give of what was proven is 3 flat words. Not locally real. The world we live in is not locally real. You can argue about which comfort to drop, but you cannot keep them both, and that is no longer a matter of opinion. It is in the data. Most people told this reach for a way to make it harmless. Surely this only matters for ghostly particles in sealed labs. Things so small they have nothing to do with the solid world of chairs and coffee and bone. Surely whatever is true down there stays down there, and up here the ordinary world keeps its definite, separate, sensible shape. That hope is exactly what the cold machines take away. Because the strangeness is not trapped in a thought experiment. We have learned to build with it. The very effects Bell exposed, the undecided states and the instant links, are the working parts of a real device, sitting in a real lab, solving real problems. We did not just prove a reality is not locally real. We started using the fact that it is not. And once you are running a machine on the broken pieces of the ordinary world, a new question arrives that is sharper than any before it. Where exactly is that machine doing its work? Go back to the cold chip at the bottom of the gold tower and look at it again with everything you now know. The qubits on that chip are held in superposition, undecided, both values at once. That is the dead realism, the no definite answer before the look, built into hardware. And to compute, the qubits are entangled with each other. Their fates tied together so that you cannot describe one without the rest. That is the dead locality. The instant link. Wired in on purpose. A quantum computer is not inspired by the Bell result. It is made of it. This is the turn that should change how you see these machines. The headlines talk about speed, about cracking codes, about new medicines. All true, maybe, someday. But step past the brochure and look at what the device actually is. It is a structure built to hold the exact features of reality that the experiments proved real and that common sense says are impossible. Engineers take the undecided state and the spooky link, the two things Einstein could not stomach, and they arrange them, tune them, and put them to work. Think about what that requires. To build a bridge, you need real steel. To build one of these, you need real superposition and real entanglement, in large amounts, held steady. If the qubits secretly had definite values all along, the machine would be no faster than your laptop. If the entanglement were just a correlation from a shared past, like Einstein's sealed letters, there would be no advantage at all. The speed comes only if the strangeness is genuine. So every working quantum computer is a standing piece of evidence. It does not just agree that reality is not locally real. It runs on that fact, and it would not run otherwise. That is why the people who build these things stopped arguing about whether the effects are real long ago. They are past it. They spend their days fighting to keep the effects alive a little longer, because the smallest leak of warmth or noise destroys the undecided state, and the machine falls back into an ordinary one. The whole engineering challenge is protecting the strangeness from the everyday world that wants to crush it. The cold, the shielding, the isolation, all of it is a wall built to keep ordinary reality out, so the stranger reality can do its work. And here is where the brochure and the mystery split apart for good. A quantum computer can, in certain tasks, do something no normal computer could ever finish. Not in the lifetime of the universe. It can take a problem with an unthinkable number of possibilities and arrive at the answer fast. Because all those possibilities were held at once in the superposed, entangled state and worked on together. The device delivers. The answer comes out, and it is correct. But stand back and ask the simple, almost childish question. The machine just performed a calculation that would need more steps than there are atoms in the universe to do the plain way. Where did those steps happen? The chip is small. It has a limited number of qubits. There is not enough material in it, not nearly, to hold all that work in any ordinary sense. And yet the work got done. The answer is real. The correctness is checkable. So where did the computing actually take place? Not as a figure of speech. As a physical question about a physical device sitting in a lab. The chip is too small to contain the work it just did. Something carried that load. And one of the leading attempts to say what that something is happens to be the most disturbing idea in modern science. A physicist who helped invent the theory of these machines put the question as bluntly as anyone has. When a quantum computer factors a number too large for every ordinary computer on Earth to crack, using more steps than there are particles in the visible universe, where were those steps carried out? His answer was not a shrug. He said the calculation was real, the work was real, and since it plainly did not all fit inside the small chip in front of him, it must have happened somewhere. His proposal was that it happened across many versions of the chip, in many parallel realities, all computing together. This is the many worlds reading, and to feel its weight, you have to back up to where it came from. Remember the measurement problem, the hole at the center of the theory. The math describes a spread of possibilities, then a measurement, then a single outcome, with no rule for how the many become one. For decades, the standard move was to say, the other possibilities simply vanish at the moment of measurement, collapse. The one you see is the one that survives, the rest are erased. A young physicist looked at that and asked a sharp question. What if nothing is erased? What if the math is just telling the truth, all the way through? The equation never actually says the other possibilities disappear. We add that part by hand because we only ever see one outcome. Strip the extra rule away, follow the bare math, and it says every possibility keeps going. The reason you see only one is not that the others died. It is that you split along with them. There is a version of you that saw each outcome, and each version is just as real, each convinced its result was the only one. Apply that to the cold chip, and the puzzle of the missing work dissolves into something worse. The reason a quantum computer can do more steps than fit inside it is that the steps are spread across the branching versions of reality. Each branch runs part of the load. The machine reaches across them, lets them compute in parallel, and gathers the result back into the one branch you happen to be standing in. The chip is not too small after all. It is borrowing room from worlds next door. To the people who hold this view, that is not poetry. It is the plainest reading of how the device works. The strangeness Bell proved, the no hidden answers, the instant links, is exactly what you would expect if every possibility is real and the branches are physically there. The undecided state of a qubit is not really undecided. It is 1 and 0 in 2 branches at once. The entangled link is not spooky at all. It is just 2 branches lined up. The machine is fast because it has help from copies of itself in copies of the world. Most physicists do not commit to this, but many of the people closest to the hardware find it the cleanest story, precisely because it requires nothing extra. No collapse, no special role for the observer, no line where the many mysteriously become one. Just the math, taken at its word, all the way down. The price for that clean math is steep beyond imagining. Everything that can happen does happen, each in its own branch of an endlessly splitting reality, which forces the question this whole story has been climbing toward, now sharpened to a point you cannot file off. If the branches are real, and each one holds a version of the chip and a version of you, then how many of you are there? And how many worlds are quietly running alongside this one? Start counting, and you cannot stop. Every time a quantum event could go more than one way, and almost every event can, the many worlds picture says the world splits. Not once a day, not once a second. Constantly. Everywhere. At a rate beyond any number we have a name for. Every atom that could decay or not. Every particle that could go left or right. Every measurement anywhere in the universe. Each one branches the whole of reality into versions where each outcome happened. The splitting does not wait for a scientist or a special device. It runs on its own all the time, in every corner of everything. That means the count of worlds is not large in the way a big number is large. It is past that. It grows without limit, faster than you can track, with every passing instant adding more branches than the mind can hold. And you are in all of the ones that lead to a version of you. There is a version of you that took the other job. A version that said the thing you wish you had said. A version that turned left this morning, and one that turned right, and uncountable versions that differ in ways too small to notice, and ways large enough to break a heart. Each one is as real as the one reading this. Each one feels like the only one. None of them can reach the others. This is the place the cold machine has led us, and it is worth being honest about how strange it is to arrive here from an engineering problem. Nobody set out to prove that reality splits. People wanted faster computers. They built a chip, cooled it, and watched it do work that would not fit inside it. To explain where the work went, one of the leading answers says it went into countless other versions of the world, running beside this one, all the time, forever. You can refuse this answer. Plenty of careful people do. But notice what refusing it costs. If the branches are not real, then the other possibilities really do vanish at measurement, and you are back to the collapse no one can explain, the line no one can locate, the act of looking that somehow turns many into one. Many worlds is unbelievable in one way. Collapse is unexplained in another. The data does not force you to pick. It just takes away the option of a calm, single, ordinary reality and leaves you choosing which strangeness you can live with. And the deepest question is no longer about a particle in a lab. It is about how many realities there are, and which one, if any, deserves to be called the real one. If every branch is equally real, then the world you are in is not special. It is just the one you happen to find yourself in, no more the true reality than any of the others. There is no main branch, no original, no backup that counts more than the rest. Only an endless tree, splitting and splitting, with a version of you on uncountable twigs of it, each certain it is home. If that is true, the question this whole story opened with takes on a darker shape. What is really there when no one is watching? Maybe everything is there. Every outcome, every version, all at once, all real, all the time, and the single solid world you feel around you is just one thin slice you can see. But here is the thing that should stop you. If reality is splitting that fast into the many branches, you should be able to feel it. You should sense the seams. The world should shimmer and blur at every choice. Instead, it sits perfectly still and solid, one smooth moment after another, with no hint of the storm of branching the theory says is happening right now. Everywhere, including inside you. So either the branching is not real, or something is hiding it from you with perfect skill. And the explanation for that hiding is its own kind of unsettling. Here is what hides it, and it is the same thing the cold machine fights every second. A qubit holds its undecided state only in perfect isolation. The instant it touches the warm world around it, a stray photon, a faint vibration, a single passing atom, the state leaks out into that environment and the blend is gone. The qubit goes from holding both answers to holding one, not because anyone looked, but because the world brushed against it. Physicists call this decoherence. It is the reason the gold tower has to be so cold and so sealed. The everyday world is constantly reaching in to settle what the machine needs to keep open. Now turn that around and point it at you. You are not a single isolated qubit in a sealed box. You are a warm mountain of atoms, soaked in light and sound and heat, touching the world through every pore at every instant. If the branching is real, you are not split cleanly into separate versions that hang apart like pages in a book. You are split so fast and tangled so thoroughly with everything around you that the branches lose contact with each other almost the moment they form. Each branch races off into its own future, unable to feel the others, because the environment has stamped them apart. That is why the world looks solid. Decoherence does not stop the branching. It hides it. The split still happens, the theory says, but the pieces are pulled out of touch so quickly and so completely that no branch can sense another. You feel like the only version of you because the other versions are sealed away from yours by the sheer noise of being a large, warm thing in a busy universe. The shimmer you expected to feel at every choice is there. You just cannot reach across to the part of you that went the other way. Sit with how neatly this closes the trap. The very fragility that makes a quantum computer so hard to build is the thing that keeps your world feeling whole. The machine is hard precisely because the world is so eager to settle things, to brush every undecided state into a single outcome and split the branches apart. Engineers spend fortunes fighting that eagerness for a few millionths of a second. You live inside the result of it every waking moment, in a world that has already been settled and split a countless number of times before you finish this sentence. And decoherence answers a question, but it opens a colder one. It explains why you only see one outcome. It does not explain why this outcome. Out of all the branches the world splits into, you find yourself on exactly one twig of the tree, and the theory gives no reason for that one. It does not say your branch is special. It does not say it was chosen. It just says here you are, on this twig, with no account of why this twig and not another. So the solid world is a kind of mercy and a kind of veil at once. It spares you the storm of branching by hiding the storm. It lets you live as though your choices land in a single reality, when the math underneath says they may be fanning out into many. The everyday world is not the whole of reality. It is the thin, settled crust that decoherence lets you walk on. But if the world is constantly being settled by contact, a sharper puzzle waits underneath. Why do we all settle on the same world? Why does your reality match mine? The answer to that has a name that sounds almost alive: quantum Darwinism. And it earns the name because it describes a kind of survival of the fittest playing out at the root of reality. The idea starts from a simple fact about how you actually know anything. You never touch the world directly. You read it off the light that bounces from it, the sound that carries to you, the photons that strike your eye after leaving the page. You learn about a thing only through the copies of its state that it scatters into the world around it. Here is the move. When a quantum system settles through contact with its environment, it does not just leave one trace. It stamps copies of its settled state into the environment, over and over, in the countless particles that interact with it. A speck of dust in sunlight throws off its position into millions of photons at once. Each photon carries the same answer about where the speck is. Anyone or anything that catches even a few of those photons reads the same fact. The world is flooded with redundant copies of the same settled outcome. That redundancy is the trick. Only certain states survive this process well. A state that can stamp clean, agreeing copies of itself across a flood of particles is a state that everyone will end up seeing. A state that smears or scrambles when it tries to copy itself never makes it into the shared record. So the environment acts like a filter. It selects the few states that copy cleanly and broadcasts them everywhere, while the fragile, undecided blends never get out of the gate. The states that survive the copying are the states we call real. This is why your reality matches mine. We are not each conjuring a private world. We are both reading the same broadcast, the same redundant copies stamped into the same shared environment. The classical, solid, agreed upon world is the set of states that proved fit enough to copy themselves loudly into everything. The moon is there for both of us, not because looking creates it fresh each time, but because its state has been broadcast in so many copies across so much light that any observer who checks finds the same answer. Reality is the consensus that survives. It is an elegant idea, and it has been tested in the lab, watching information about a system spread into its surroundings exactly the way the theory predicts. It tames the wildest fear. You are not trapped in a solipsist bubble. There is a shared world, and it is shared for a concrete reason. But notice what it quietly admits. The solid world is not the bottom layer. It is a broadcast, a surviving copy. The real substrate is still the undecided quantum state underneath, and the world we agree on is the advertisement it puts out, the version fit enough to be seen by many. We do not live in the base reality, we live in its most redundant copy. And that raises a question quantum Darwinism cannot settle on its own. If reality is the version that gets broadcast and agreed upon, what happens when two observers genuinely cannot agree? What if there is a situation where your settled fact and mine are different, and both of us are right? A physicist who helped build the atomic age imagined exactly that, and the scenario still has no clean way out. Picture a laboratory and a single observer inside it. Call her the friend. The friend runs a quantum measurement. A particle in superposition, two possible outcomes, and she checks it. For her, the measurement is over. The blend has settled. She sees one definite result and writes it down. As far as she is concerned, a fact has happened in the world. Now stand outside that lab and seal it perfectly. No light, no sound, no signal escapes. From outside, you, Wigner, treat the whole lab, friend and particle and notebook together as one big quantum system that has not yet been measured by you. And by the strict math, that whole system is still in superposition, not settled. The friend and her result are smeared into a blend of both outcomes, because from your sealed vantage point, nothing has yet brushed against the lab to settle it. So you have two accounts of the same moment, and they do not match. Inside the lab, the friend is certain. She saw one outcome. A fact is fixed. Outside the lab, you are equally entitled to say nothing is fixed at all, that the friend herself is in a superposition of having seen both. One of you holds a settled single fact, the other holds an unsettled blend, and nothing in the theory says which of you is wrong, because the theory was built to let each of you apply it from where you stand. For a long time, this was waved away. The friend is a big warm thing, people said. Decoherence settles her result instantly. Of course the fact is real, but that misses the knife in the thought experiment. The point is not whether the friend feels settled. She does. The point is that the math, applied honestly from outside, says the result is not yet a single fact for you. The theory permits two observers to hold contradictory accounts of the same event, each correct by its own lights, with no rule to break the tie. This is worse than the cat. The cat was one system in a blend, troubling but distant. Here the blend contains a conscious observer who has already settled the matter for herself. Her certainty does not erase your superposition. Your superposition does not erase her certainty. The same event, at the same time, is both a finished fact and an open blend, depending only on where you're standing and how sealed the walls are. The natural response is to insist that surely there is a fact of the matter. Surely the friend either saw the outcome or she did not. And your outside description is just incomplete, missing what really happened inside. That is the comfortable move. It is also exactly the move that a stack of recent results has begun to take away, because the disagreement between the friend and the outsider is not just a story. It can be pushed, with care, into a form where the two views make different predictions about what a real measurement will find. And once a thought experiment makes a testable prediction, it stops being philosophy. What that test reveals is a wall. A short list of reasonable beliefs about facts and observers, every one of which feels obviously true, and a proof that they cannot all be true together. Lay the beliefs out, and each one sounds like plain sense. First, that a measurement gives one real outcome, a single fact, not a blend. Second, that what is true for one observer is true for all. That if the friend saw a result, that result is a fact for everyone, including you outside the lab. Third, that observers far apart cannot instantly force each other's results, the locality bell already strained. Fourth, that an experimenter is free to choose what to measure. Each of these is something almost no one would think to doubt. They are the quiet flaw under all of science. The new result, sharpened from the friend scenario, proves they form an impossible set. You can hold any of them. You cannot hold all of them at once. Take the friend's settled fact, add that her fact is everyone's fact, keep locality, keep free choice, and run the math through to a prediction. The prediction contradicts what quantum mechanics says the experiment will show. So at least one of those four floorboards has to be ripped out, not bent, removed. This is a different kind of blow from Bell. Bell killed local realism. The idea of definite properties sitting underneath, untouched by measurement. You could absorb that and still believe something steady. You could still believe that when a measurement does happen, it produces one fact. And that fact is the same for everyone who asks. This result reaches in and pulls at that last steady thing. It says even the act of two observers sharing a single agreed outcome is not guaranteed. One of the beliefs that lets us all live in one common world is on the chopping block, and the theorem will not tell you which. Look at what each option costs. Drop the first belief, and a measurement no longer gives a single outcome, which slides you back toward branches and many worlds. Drop the second, and the friend's fact is genuinely not your fact, which means facts themselves are local to the observer, with no universal record. Drop locality, and you are back to instant influence across space, now reaching into measurements made by people. Drop free choice, and the experimenter was never really free to choose, which opens a door we will have to walk through later, and it is a grim one. There is no painless exit. Every escape from the theorem requires giving up something that felt like bedrock. And the option that has unsettled physicists the most is the second one. The idea that there might not be one shared set of facts at all. That what counts as having happened could depend on who you ask, with no higher court to settle it. For most of history, that would have been a fever dream. The kind of thing no serious person would test. But the friend scenario, for all its strangeness, turned out to be buildable. Not with a conscious person sealed in a room, with something smaller, cleaner, and good enough to count as an observer for the purpose of the proof. The impossible set of beliefs could be put on a table and checked against reality. And so they built it. You cannot seal a human friend in a perfectly isolated box and treat her as a quantum blend. But you do not have to. The theorem only needs an observer, something that performs a measurement and records a result. And a measurement, stripped to its bones, is just one system reading another and storing the outcome. A single particle can do that. So the friend in the lab became a single photon, or a small quantum device, playing the role of the observer, sealed well enough that the outside view could still treat the whole thing as one unsettled system. The setups are intricate, but the shape is the friend scenario made real. Inside, a tiny observer makes a measurement and gets a definite result, its version of the friend writing in her notebook. Outside, the experimenter treats that whole inner measurement as a system still in superposition, the way Wigner treats the sealed lab. Then, the experimenters do the thing the thought experiment only imagined. They check both descriptions against each other by measuring correlations between the inner results and the outer ones. The same kind of correlation Bell taught us to count. The results came back on the side of the strangeness again. The data matched what quantum mechanics predicts when you take the outside view seriously. The view in which the inner observer's settled fact is not a settled fact for everyone. The correlations broke the limit that would hold if the four reasonable beliefs were all true together. The experiment did not point to which belief fails. It confirmed that they cannot all stand. The impossible set is impossible, not just on paper, but in the lab. Now be careful here, because this is the kind of result that gets stretched into nonsense, and the truth is strange enough without the stretching. These experiments do not prove that conscious people experience contradictory realities. The observers were tiny quantum systems, not human minds, and there is real argument about whether they count as observers in the full sense. The honest status of this is open. It is a live, contested frontier result, not a settled verdict like Bell. Mark it that way and keep it there. But mark this too. The experiments were built to find out whether the friend scenario could ever be more than a story. Whether the disagreement between the inner and outer view could show up in real numbers. It can. The numbers came in on the side that says observer-dependent facts are not ruled out. The door that everyone assumed was locked. The door to a world where what happened depends on who is asking turned out to be at least ajar. That is enough to change the question one more time. Bell took away a real world that exists independent of measurement. These tests put pressure on something even more basic. The idea that whatever did happen, happened once, the same for all of us. If that goes, then the disagreements between observers are not errors to be corrected. They are the way reality is. So the unsettling possibility has to be said plainly, even while it is still open. Maybe there is no single story of what happened. Maybe the universe does not keep one master record. Think about what a fact is supposed to be. It happened. It happened once. It is the same for everyone, whether they were there or not. Whether they ask now or in 1,000 years. The friend saw heads. That is true for her, for you, for anyone. The past is fixed and shared. This is so deep in us that to question it feels less like physics and more like madness. And yet the frontier results lean, gently and unmistakably against it. Hold the friend scenario in its sharpest form. Inside the sealed lab, the result was heads. The friend is certain and she is right for her. Outside, the description that matches the experiment treats the result as unsettled, and that description is right too, for the outsider. There is no measurement either can make that crowns one of them the true account and demotes the other to a mistake. Both are complete. Both are correct. They simply do not agree. The result was heads, and the result was not yet anything, at the same time, in the same world. If that is how reality works, then a fact is not a single stone everyone can walk up to and touch. It is more like a reflection that depends on the angle you stand at. The friend's angle gives one fact. The outsider's angle gives another. Neither angle is the privileged one. There is no view from nowhere, no master ledger above all observers where the one true entry is written. The accounts are real, and they are relative, and that is the end of it. This is the deepest cut so far. Deeper even than the broken realism of Bell. Bell let you keep a single shared world, just a strange one. This takes aim at the sharing itself. It suggests the universe might not store one history, but a web of accounts that are each valid from their own place and do not always line up. The thing we call the past, the agreed record of what occurred, might be a local convenience, holding only because we are all large, warm things soaked in the same broadcast, never sealed off from each other enough to disagree. And that is the only reason your world feels whole. You and everyone you know are decohered, leaky, in constant contact, so your accounts are forced into agreement by the flood of shared copies. The disagreement only shows up in the lab, in tiny sealed observers kept clean of the broadcast. But the lab is not making the strangeness. It is revealing what the everyday noise normally papers over. The single shared reality you trust may be a side effect of never being truly isolated, not a law of the world. Keep the honest label on this. It is open, contested, unfinished. No one has shown that human observers can hold contradictory facts. But the direction of the results is one direction, and it is not back toward comfort. Every test that could have rescued the single shared world has instead nudged it further out of reach. There is one more place the ground gives way, and it is the strangest of all, because it does not threaten the present or the sharing. It threatens the order of time itself. There is an experiment where a choice made now appears to decide what a particle did in the past. Go back to the two slits, but add a cruel twist. A particle goes through the barrier and heads for the screen. Along the way, you have a setup that can either tag which slit it took or leave that information forever unknowable. If the path is knowable, the particle behaves like a grain through one slit. If it is unknowable, it behaves like a wave through both. You already know this. Here is the twist. You wait. You let the particle pass the slits and travel onward, well past the point of choosing, and only then, after it has already done whatever it did at the slits, You decide whether to keep the witch path information or erase it. The decision comes late, after the particle is long past the barrier, and yet the outcome obeys the decision. Erase the path information, even after the fact, and the wave pattern is there in the data. Keep it, and the pattern is gone. The particle's behavior at the slits, which already happened, lines up with a choice you had not yet made when it happened. The delayed choice eraser, run many times, shows this cleanly. What you decide now is matched by what the particle did then. This sounds like the present reaching back to rewrite the past, and that is exactly how it feels to read the raw result. The temptation is to say you sent a signal backward in time and changed history. But look closer, and the truth is subtler and, in a way, worse. You never see the pattern in the live particles. It only appears when you sort the results afterward, pairing each particle with the record of the late choice. You cannot use this to send a message to yesterday. The order of cause and effect is not openly broken, but the correlation is undeniable. The data behaves as if the past stayed open, unfixed, until the later choice was in. So the past was not done when it looked done. The particle did not commit to wave or grain at the slits and wait for you to catch up. It left the question open, carried it forward, and let a choice made later settle what it had been all along. The fixed, finished past, the one thing we were sure could never be touched, shows the same undecidedness as everything else. It holds two possibilities until something settles it, even if the settling comes after. Put this beside the friend, and the picture darkens. The friend scenario said, maybe there is no single shared present. This says maybe there is no fixed single past either. The two pillars holding up our sense of a solid history, that what happened is one thing and that it stays happened, are both bending under the same kind of pressure. The undecided state is not confined to small particles in the now. It reaches into the record of what already was. There are ways to explain this without literal time travel, and physicists have built them. But each one asks you to give up something you would rather keep. To save the ordinary past, you have to accept an idea that is, in its own way, just as hard to live with. The first way out is to take the backward arrow seriously. If a choice now lines up with a particle's behavior, then maybe influence really can run from the future into the past. This is retrocausality, and it is not a crank idea. Serious physicists pursue it because it can make the quantum strangeness look almost ordinary again. If the future can reach back, then entanglement is not spooky action across space. It is a handshake across time. The link between two particles is arranged by influences that travel both directions along their paths, meeting in the middle. The weirdness dissolves. The price is that the future helps right the past, and because no longer strictly comes before effect. Sit with that price. Everything you do rests on the past being fixed and the future being open. You act now to shape what comes. Retrocausality keeps the equations clean by loosening that. It says the arrow of time, the one thing that feels most certain of all, is not fundamental. The universe is a single fabric in which later and earlier lean on each other. And the sense that the past is closed is just how it looks from inside. Many find this easier to swallow than many worlds. It is still a knife to the throat of common sense. The second way out is stranger still, and it lives behind the free choice loophole Bell could never fully kill. Remember the assumption that the experimenter freely chooses what to measure. Drop it. Say the choices were never free. Say that everything, the particles, the detectors, the settings, even the thoughts in the experimenter's head, was fixed together from the start of the universe. all correlated by initial conditions laid down long ago. Then the Bell results need no spooky link and no dead realism. The particles seem to coordinate across space only because the whole experiment, choosers included, was choreographed in advance. This is superdeterminism. It saves locality and realism both. It does so by taking everything else. Because if it is true, there is no free choice anywhere, ever. Not in the lab, not in your life. Every measurement, every decision, every word of this script, and every thought you are having about it was set in motion at the beginning and could not have gone otherwise. The universe is a film already shot, and you are watching your own scene believing you are improvising. Superdeterminism rescues the ordinary world by erasing the chooser. Almost no physicist accepts it, not because it can be disproven. It is built to be hard to disprove, but because it costs the very thing that makes science possible, the freedom to test one thing against another. So count the bill. To keep a single fixed reality, you must accept either branching worlds, or observer-dependent facts, or backward causation, or a universe with no real choices in it. Those are the options on the table. Every one of them is monstrous to common sense. The data does not let you off with anything smaller. This is the true weight of the cold machine. It does not just compute. It backs you into a corner where every wall is a wonder or a horror. And while the theorists argue over which wall to lean on, the engineers have quietly gone further. They have started using entanglement to build models of space and time themselves. And what those models suggest about the floor of reality is the strangest turn yet. On some quantum chips, researchers are no longer just computing numbers. They are building little models of space-time. The idea grew from a discovery that looked, at first, like a coincidence in the math. The equations that describe how entanglement is woven through a quantum system turned out to match the equations that describe the shape of space in Einstein's theory of gravity. The way entangled threads connect the parts of a quantum state mirrors the way distances and curves connect the points of space. Two fields that should have nothing to do with each other were speaking the same language. The lesson many drew from this is staggering. Space might not be fundamental, it might be made of entanglement. In this picture, the reason 2 points are near each other is that the quantum pieces sitting there are strongly entangled. The reason 2 points are far apart is that their entanglement is weak. Cut the entanglement between two regions, and the space between them does not just empty, it tears. Distance itself, the plain fact that here is not there, would be built out of the same quantum links Bell proved are real. Geometry would be the large-scale shape of a web of entanglement underneath. On the chips, researchers test pieces of this by entangling qubits in carefully chosen patterns, and watching quantities behave exactly the way a patch of curved space, even a model of a wormhole, is predicted to behave. They are not bending real space-time. They are running a system whose entanglement is arranged so that it obeys the same math as gravity and seeing the prediction hold. It is a model, careful and limited, and the people doing it say so plainly. But the fact that it works at all is a clue, and the clue points down toward a layer beneath space. Step back and feel the reversal. We have always treated space as the stage, the empty container that everything else sits inside. Particles move through it. Fields fill it. Even the quantum strangeness seemed to happen within space, two entangled particles linked across a distance that was simply there. Now the order flips. The distance is not the stage. The entanglement is. Space is what the entanglement looks like when there is a lot of it, arranged just so. The container is built from the contents. If that holds, the spooky link stops being a thread stretched across space and starts being the thing space is made of. Einstein's nightmare, the instant connection across any gap, would not violate the structure of space. It would be more basic than space, one of the threads from which distance is sewn. The reason entanglement does not care about distance is that it comes before distance. It is closer to the floor of reality than the geometry we have always taken as the floor. And once space itself looks like it is built from something more basic, the obvious question is what that something is. The entanglement web is described at bottom by relationships, by correlations, by which part agrees with which. That is not stuff. It is not matter or energy in the old sense. It is a pattern of agreement, a structure of information. And a growing number of physicists think that is not a metaphor, but the literal bedrock. That the thing everything else is made of is not particles at all. The proposal is bare and strange, and it keeps gaining ground. At the bottom of reality, beneath the particles, beneath the fields, beneath even space, there is information. Not information about something else. Information as the something. The relationships, the yes or no answers, the bits, are the actual material of the world, and matter and space and energy are patterns those bits fall into. One physicist compressed the whole idea into a single phrase, that everything comes from bits. That every particle and field, every it in the universe, draws its very existence from answers to yes or no questions. The world, on this view, is built from the answers, not the things. It sounds like wordplay until you notice how much points toward it. The double slit said the world responds to what can be known. The Bell test said there are no hidden values, only outcomes that come into being when a question is asked. The friend result said a fact might depend on who holds the information. The space-time models said geometry is built from entanglement, which is itself a pattern of correlations, of shared information. Again and again, when physicists dig to the bottom of a result, they do not find a tiny solid thing. They find a relationship, a question and an answer, a bit. A quantum computer fits this picture too well to ignore. It does not push matter around. It manipulates pure information, superposed and entangled, and out comes an answer to a problem about the world. If the world is, at its root, made of information, then a quantum computer is not modeling reality from the outside. It is working in the same currency reality is built from. That is why it can reach into the structure of a hard problem and pull out a result that no machine pushing ordinary matter around could find. It speaks the native language of the world. This is the quiet thread running under everything in this story. The cold chip, the dead realism, the broken locality, the disagreeing observers, the open past, the space woven from links. They all point the same way, toward a reality whose deepest layer is not made of stuff at all, but of relationships and the answers to questions about them. The solid world of matter is the surface. Underneath is something more like a vast structure of information, settling into the shapes we call particles and space and time. If that is what the world is made of, a strange door opens and it is hard to close again once you have seen it. We know exactly one other kind of thing that is built out of pure information and runs by processing it according to rules. We build them. We cool them in gold towers. A system whose base layer is information, that updates by fixed rules, that produces a definite world of experience out of an underlying field of possibilities, is not just like physics. It is also the exact description of a computation. The people pushing the information idea are not saying the universe is a simulation. Most of them would wince at the leap. They are saying the bedrock is information, and that is a careful, serious claim with real support. But the moment you say the flaw of reality is information being processed by rules, you have described something. And the thing you have described is impossible not to recognize. The question almost asks itself, and the machines we built are the reason it will not stay quiet. So here is the question the cold machines drag into the open, and it has to be marked clearly as open because it is the one most easily abused. If the deepest layer of reality is information processed by fixed rules, producing the world we see, then is reality something being computed? Is the universe a bottom running? Notice this is not a wild leap from nothing. It is the plain shape of where the evidence has been pointing. A world that holds many possibilities until a question is asked. A world with no hidden values underneath, only outcomes generated on demand. A world that seems to care about what information can be known, that settles things through copying and broadcasting, that builds space out of correlations, that runs on a bottom layer best described as bits. Every one of those is a feature you would expect if reality were less like a thing and more like a process. Less like a stage full of objects and more like a computation unfolding. There are even details that make people uneasy in this direction, and they deserve naming without overreach. The world has a smaller scale, below which distance and time seem to stop meaning anything, the way an image has a smallest pixel. The world has a hard speed limit, the way a processor has a clock rate. The world hides its undecided states the moment you are not interacting with them, settling them only when checked. The way a well-built program computes a detail only when something needs it to save work. None of these proves anything. Each has other explanations, but laid side by side, they form a pattern that is hard to unsee. And the cold machines are the thing that made the pattern visible, because they are the first devices that work by manipulating that bottom layer directly. Hold the honest line here, because it matters more than the thrill. This is an open mystery, not a confirmed result. Nothing in any experiment proves the universe is computed. The simulation idea, in its loud popular form, is not science, because no one has found a way to test it and find it false. What is real is the chain that leads up to it. The dead local realism, confirmed. The information at the bedrock, seriously argued. And the resemblance between that bedrock and a computation, undeniable once you look, even if it proves nothing. The machines did not answer the question. They sharpened it until it could not be ignored. And that is the unsettling gift of the cold chip. It was built to solve problems. In solving them, it works by reaching into the layer of reality where matter dissolves into information and possibility. The layer Einstein refused to believe was the real one. It runs on the broken pieces of common sense, and it runs perfectly. Every successful computation is a small proof that the strange layer is real and usable. And the more we use it, the more the universe looks less like a place and more like a process. Less like a thing that is, and more like a thing that is happening. We may never know. The question of whether reality is computed may sit forever just past the edge of what an experiment can touch. The same way Einstein's bet sat for 30 years before Bell found the crack. Or someone may yet find the crack in this one too. For now, it stays open, the largest loose thread the machines have pulled, hanging there, refusing to be tied off. But even with that thread hanging, it is worth asking what the machine has actually settled and what it has only stirred. Because the two get blurred constantly, and the truth is sharp enough without the blur. So separate them cleanly, the proven from the open, because this is the only honest way to carry what we have. Start with what is settled, what no serious physicist disputes, what experiment has nailed down so hard that the people who did it were given the highest prize in their field. Local realism is dead. The world is not both definite and local. Things do not have all their properties sitting fixed and hidden before you look, while staying safely separate across distance. One of those comforts is gone, the experiments forced it, and the loophole-free tests removed every excuse. This is not interpretation. This is fact. The ordinary picture of reality, the one every person walks around with, has been measured and found false. Next, the working machines. Quantum computers run on exactly the features that proof exposed. The undecided states and the instant links. That is not a theory about them. It is how they are built and why they work. Every successful quantum computation is a standing demonstration that the strange layer is real, usable, and not going away. This too is settled. Now the open ground, and it is vast. Where the computation happens, whether in branching worlds or somewhere else, is not settled. It is one reading among several, the cleanest to some, unbelievable to others. Whether reality splits into countless versions of you is not settled. Whether facts are shared by all observers or depend on who is asking is not settled, though the frontier results lean uncomfortably away from sharing. Whether the past stays open until settled later is not settled. Whether the future reaches back, or whether choice is an illusion, not settled. Whether space is built from entanglement, promising but unproven. Whether the bedrock is information, seriously argued, not confirmed. Whether reality is computed, wide open, perhaps untestable. See the shape of it. One hard floor, and above it a tall, dark room full of doors. Every door leading somewhere stranger, none of them locked, none of them proven. The mistake is to collapse the two. To say the machines proved we live in a simulation, or proved many worlds, or proved that nothing is real until observed. They proved none of that. What they proved is narrower and, in its own way, heavier. They proved that the calm, ordinary, definite, separate world is not the true one. They did not tell us what the true one is. That is the real state of things, and it is enough. You do not need the wildest door to feel the floor move. It is already established, with the full weight of experiment behind it, that reality is not what it appears to be. The appearance is the broadcast, the surviving copy, the thin, settled crust. Underneath is something that does not obey the rules your senses taught you. Something the machines touch every time they run. Something we can use without being able to say what it is. And so the question the story opened with comes back around. No longer a piece of mood, now sharpened by everything between. We have proven the watched world is not the whole of it. We have built machines that work in the unwatched layer. Which leaves the oldest version of the question, the one a child could ask, and no physicist can fully answer. What is really there when no one is watching? For most of history, the answer was obvious. The world is there, the same as when you left it, going about its business whether or not a pair of eyes is on it. The cup stays on the table. The moon hangs in the sky. The cold chip sits in its tower. Of course they are there. To doubt it was a game for philosophers, not a claim with a number attached. The machines took the obvious answer away, not by argument, by measurement. We now know the world does not carry all its properties fixed and waiting when nothing interacts with it. We know the undecided state is real, that it settles only on contact, that the solid world is the version that survives the settling and gets copied loudly enough for everyone to agree on. When no one is watching and nothing is touching, The strict, honest answer is no longer the cup is on the table. The honest answer is that there is a spread of possibility, holding more than one outcome, waiting for the brush of the world to make it one. The watching, or the touching, is part of how the one outcome comes to be. This is not mysticism, and it does not mean your mind makes the moon. A passing photon counts as a watcher. The world is settling itself constantly, everywhere, through endless contact, which is why you never catch it undecided. But strip the contact away, seal it off, cool it down, keep the world from brushing against it, and the thing you are left with is not a small solid object hiding in the dark. It is a held breath of possibility. That is what the cold machine protects. That is what it computes with. A piece of reality kept, on purpose, in the state it lives in when no one and nothing is watching. So sit with where that leaves you, because it does not stay safely in the lab. You are made of the same stuff as the chip. The same rules ran in you before you were born, and will run in you after. The solid, single, definite life you feel yourself living is the broadcast version. The surviving copy, the crust. Underneath your own certainty is the same undecided layer, settling moment to moment through your endless contact with the world, into the one stream of experience you call your life. You are not standing on the floor of reality. You are standing on its surface, and the surface holds because you never stop touching it. The machines did not give us comfort. They gave us a fact, and the fact is cold. The world you trust is real enough to live in, and not deep enough to be the truth. There is a layer beneath it that does not match anything your senses were built to grasp, and we have just begun to reach into it, and we cannot yet say what it is. The next time you are alone, and the room is still, and nothing is happening, remember what the cold chip proves. The stillness is not empty, and it is not settled. It is only waiting. Look away and see if it stays.